Hello, everyone. Thank you for joining the talk today. So I'm going to talk about Morpho, a lending protocol, and take you through the journey that I personally went into DeFi, the reason why I went to create Morpho, and why it's important in the bear market conditions to consider this kind of protocols that I'm going to present in a second. So when I first came into DeFi, it was back in 2008 and 19, around that. And at the time, so I don't know if some of you knew about Dharma or Island, you had those very peer-to-peer protocols that basically you had to post an offer and wait for someone to take your offer, right? So like the classical traditional finance peer-to-peer way, but on-chain. And I don't know if some of you used it, but it was quite a pain to use, because what happened is that you were saying, I'm lending at 2% this amount of liquidity, and then you had to wait for someone. But in 2019, like, nobody was using the blockchain to lend and borrow crypto assets, so you waited for nothing. And so the good thing with those protocols was that all the liquidity that you lent was actually borrowed by someone else. But the downside is nobody was there, so you were not getting any yields. So if we were to put this protocol, ETHLend, on the graph, it was actually here. So you have a good capital efficiency, but it's not liquid. Okay, so I kind of stopped DeFi after this for a while and went into like modeling of the different protocols out there. And in 2020, when Compound came out with its lending pool and DeFi Summer and everything, it was really a breakthrough. And I just wanted to take a step back on why it was a breakthrough at the time. Is that because Compound and then Aave really enabled a liquid experience of DeFi, meaning that anyone could borrow at any time, withdraw at any time, and almost any amount, right? If you go to Aave today, you're able to borrow billions, right? And on Compound as well. And this is amazing because from a smart contract perspective, you just click the button and you start earning yields, or you just click the button and you get your liquidity. And it was, at the time, a very needed property that we did not have. Yet, it came at a cost, and this is the cost of efficiency, because we'll have the occasion to tackle that in a second. But on those pools, if you want to be able to withdraw billions, you have to have billions of idle liquidity somewhere in those smart contracts. So if we were to position the, oh, sorry, I think I got the wrong decor. Okay, never mind. So if you go to Compound website, for example, you'll notice that you have a huge spread between the lending side and the borrowing side. So if you try to lend money, you most likely get 1% APY, while if you want to borrow money, you'll be more on the 3% APY range. And, well, the reason for that is because on Compound, on Aave, you have much more lenders than you have borrowers. Okay? So you have huge pools of liquidity on which you have many suppliers sharing the revenues of few borrowers. And for example, if you have 3 lenders for 1 borrower, a borrower is going to pay for the 3. So this is what creates the spreads in the Compound protocol and the Aave protocol. So this difference. So Aave and Compound are nice because they're liquid, but they're not nice in the sense that they're less efficient, and they have this huge interest gap. And Morpho in all this is like Aave and Compound. So it's a lending protocol. It works exactly the same way. So you supply and borrow crypto assets. You have like the same liquidity available. So on Morpho, which is live right now, you can borrow billions of liquidity. You have the same collateral factors, the same oracles. Everything is the same. You have the same functions. The only difference is that we have additional efficiency, and thus improved rates for both lenders and borrowers. So if you were to place Morpho on the graph, it would look like Morpho is capital efficient and is liquid at the same time. So the question is, how do we do it? Well, actually, that's quite simple. So if you're a user of Morpho and you want to lend liquidity, what's going to happen is you're going to provide, for example, ETH. So ETH is going to go to Morpho, and Morpho is going to put it to the pool. And then a borrower comes in, and the borrower is going to supply some collateral. And after providing the collateral, well, Morpho is going to click the borrow button, and Morpho is going to take the lender's liquidity that is in the pool to give it directly to the borrower. And what is important to understand at this point is that lenders and borrowers are not interacting with the pool directly now. They are interacting with each other. So they don't have to share with the pool what their interest rates are. So let's take a graph so that we all understand. The idea is that you start as a supplier. So let's say you're the very first supplier of Morpho. You're here. You're going to be put on the pool by Morpho. So you're going to have the interest rate of the pool, which is the one here. And then a borrower is going to come in. Okay. And as we said, Morpho is going to take the liquidity from Compound and is going to match it with the borrower. And there, they are peer-to-peer. So they can have a rate which is independent from the rates of the pool. And here what's going to happen is that Morpho is going to put the rate that is here in the middle. And that is, for both parties, is going to be better. So it means that the lender is going to have more yield, and the borrower is going to pay less. And at some point, someone of the two parties want to leave, right? For example, I was lending capital, and I want to get my capital back. So what's going to happen in that scenario is that Morpho is going to disconnect the lender and the borrower and have the other party fall back to the underlying pool. So this is what's happening here. So Morpho is an academic and research-based project that we've been working on for more than a year and a half now. So we're publishing papers. The first of them is a white paper with like all the vision and everything in it. I suggest that if you're interested in learning more in like the mechanics of the protocol, you should just take a quick look. It's called like whitepaper.morpho.xyz. It's quite an easy read, to be honest. And now what I wanted to tackle is a specific property of Morpho that enables Morpho to scale with its underlying blockchain. But before that, I think it would be probably interesting to make sure that everyone has understood the protocol. So if you guys have questions, maybe we can take some of them now. So do you have questions or for the protocol specifically?
Can we get this on? Yeah.
Hi. So you have to match when you make the peer-to-peer action from the borrower and the lender. You have to match the exact same amount?
Yeah, okay. So in Morpho, you don't need to match the exact same amount. We're matching liquidity and not users. So it means that a user that, let's say, has 1 million can be matched with multiple users that have like 100K, for example, or whatever, like whatever amount. So there is no need to find the exact match, okay? Since everybody that is matched peer-to-peer is at the same rate, it's kind of fungible to some extent, right? Someone can be matched with someone or with someone else, it does not matter.
So as a lender, I can have one part of my money in peer-to-peer and the other part in a pool.
Exactly, yeah. And then the APY you're going to experience is actually the average of the two. And it's going to be strictly better than what you have on the pool. So the main idea to understand is that you have one Morpho for each lending pool. Like you have Morpho compound for compound, which is like, we have Morpho AAV for AAV, et cetera, et cetera. And if you're using compound, then Morpho compound is basically going to be an improvement of your yield because you preserve the same liquidity, you preserve the same risk model because we replicate the liquidation experience, yet you're going to be matched peer-to-peer. So you're going to have an improvement of your yield. It's kind of a capital efficiency boost. Okay.
So if the supply rate is always better on Morpho than compound, in an extreme example, all the lenders would go on Morpho. So wouldn't you at some point run into this problem where if one of the loans on Morpho needs to disassemble, there's no fallback liquidity back on Compound because everybody went to Morpho.
It's a good question. So first, what we claim is that Morpho Compound is going to be as liquid as Compound itself, meaning that if Compound is not liquid, then we're not liquid as Morpho Compound. Okay. Yet, on lending protocols, you usually have more lending than borrowing. So you will always have an excess of loans, like of liquidity that is supplied, that will end up in the pool. But you can have discrepancies between markets where you have markets that are dried up. And in that case, Compound is illiquid. And we are too.
More questions? Do you want to move on?
Great.
Okay.
So the other topic I wanted to tackle today is that, so we've seen together that in the past, we started with very traditional approaches, meaning peer-to-peer, like some of you may remember Oasis DEX, that was basically the equivalent of Eastland indexes. And for lending, you had Eastland and Dharma. And we progressively moved to those pool models, like Uniswap, like Aave, Compound, etc. And what I'm trying to say here is that we were constrained to do so because of blockchain limits, so gas inefficiencies, but also because of activity limits, right? You have low activity in the blockchain, you don't have professional market makers on-chain in 2018, so you're not able to build a book of orders at the period of time. And I wanted to make an analogy that, so we built those pool protocols that turn out to be less efficient than what could a book be, and to reflect on the gas consumption of those protocols. I just showed here the size of a block and the space that it takes to execute an algorithm that is based on the pool or an algorithm that is peer-to-peer. So for example, if you take a peer-to-peer order book on-chain, well, depending on the model, but most models will run into DDoS attacks, or will run into out-of-gas issues, or out of gas limit exceptions, meaning that you're going to consume too much gas because you have to loop for all the orders of the book. So you end up with problems, obviously. And the very nice properties that we had with pools is that those protocols are very simple. And they have a constant algorithm, a constant cost algorithm that is contained in a very small space of the block. But again, sacrificing efficiency. So one is costly but efficient, and the other is not costly but inefficient. And so the goal of Morpho is to introduce a new kind of design where DeFi protocols in general can be hybrids, where you start by doing peer-to-peer matches. You start by doing efficiency, which is the part that is represented here. And whenever you need to stop, because, for example, you're running into gas issues, like gas is becoming too big, then you can terminate the protocol with a pool call, so a call to the lending protocol that is based on the pool, or to the DEX that is based on the pool. So what we're trying to build here with Morpho is a hybrid protocol that is strictly better than the underlying protocol by using it and making it more efficient. Okay, and another cool property that I think was cool to highlight in this talk was that with protocols that are built like this, you see that there is a variable part of peer-to-peer, right? The more peer-to-peer you do, the more costly, but the more efficient. And then if you think of multi-chain, it's very interesting because not all blockchains scale the same way. And if you have a blockchain like Ethereum that is very constrained, well, you'll be thinking of an hybrid algorithm where you have a little part of it that is using peer-to-peer matching. And you have a little bit of extra efficiency, and then you go on the pool to finish your order. But as blockchain keeps evolving, you could imagine that the part of peer-to-peer matching that is done is bigger and bigger, thus enabling more and more capital efficiency. So what I'm trying to say here is that capital efficiency in DeFi comes at the cost of complexity, and complexity is enabled with blockchain and performant blockchain. So what I'm seeing in the future for DeFi is an increase of the complexity of the protocols that is going to be also enabled by the increase of the efficiency of the blockchain applications. And having hybrid algorithms enabled to scale progressively with the blockchain. Okay, one last thought is that, well, recently we came into, of course, this bear market where many protocols took risks that were probably deemed to be too high to such a point that it went bankrupt. And I wanted to highlight that we may be entering a new cycle for DeFi where we should probably start to stop forgetting about the 20% APY that we were looking at with, you know, artificial yields and everything, but maybe look more into very deep and complexity so that we can get a +1% yields, but this one is hardly one, and it's a pure capital efficiency optimization. So this is the goal of Morpho and what we're doing in lending, but I'm sure many other protocols will pop up in other realms and will use those hybrid mechanisms. Thank you very much.
Thank you. Questions? Thank you, Paul. Questions?
Thank you for the presentation. If we come back to this optimization for small people that have small amounts to do peer-to-peer lending, I think with Morpho you will favor it or take first a big amount so that you have only one transaction maybe to do, than aggregating a lot of small liquidity.
Yeah, that's a very good point. So in order to, so this is about probably this part where we're doing peer-to-peer matches. So in Morpho, you have a module called the matching engine module where you have to decide who is going to be matched with who. Okay? And the goal of this matching engine is to optimize multiple parameters like the efficiency of the protocol, but we have also in consideration the gas costs. And indeed, if you have many small users, then matching a 1 million guy with a bunch of $1 guy does not make sense because you'll have to do 1 million iteration in the matching engine. And this is just not going to work. So in Morpho, what we're implementing is a free heap. So it's a data structure that has a sense of ordering in such a way that the transaction have the lowest gas cost and start matching with deep liquidity first.
Great. Well, we can continue this discussion outside. This room is going to be taking a break now for about a half an hour. Thank you again, Paul, for your presentation.